Hello friends, and welcome back to the bench, on which we have 500 watt in ATX. Is it 500? Yes, max 500 ATX PSU. When I received it, I connected it to the tester. It showed me all the good voltages, including 3.3, V1, V2, everything great. However, 12 volts was fluctuating at 12.3, 12.4, and 5 volts was low. I think it went as low as 4.9 on this meter at least, and 5.0 I think was the highest. So 5 volts was low, but I did something that I normally never do, and I connected a load, and it went dead. Afterwards, it doesn't turn on anymore. So, well, actually, if you switch it on, I'm gonna switch it on now, and see, it did a little spin. The sound, I could hear the sound when the transformer just suddenly started working. And on 12 volts on the oscilloscope, I see a spike to 1 volt, about 1.4. It says peak to peak over here 107, but based on the grids, this is the 500 millivolts, so that's closer to 1.5, 1.4 maybe. Anyways, it goes for 100 milliseconds. So this distance is 100 milliseconds, after which it goes down to about let's see, vertical, about 250 millivolts. The reason, or why is the 100 milliseconds significant here, is because PG will have to go high after 100 milliseconds and before 500 milliseconds. So from here to here, it needs to start somewhere here in this region. So that is basically 2 points I want to make based on this observation. What's happening with the PSU? Because one thing I forgot to mention, the standby voltage is fine. PS on is at 4 volts. Standby 5 point something. So the standby still works. The output doesn't work anymore. So 2 points I wanted to make. Number one, I connected a load to the PSU before opening it up, doing a visual inspection and checking the caps, checking for shorts, checking for anything unusual. So you could conclude that I broke it by connecting the load. So I kind of just started drawing a lot of power from it, and maybe the caps, maybe there was some liquid damage in it. We don't know because we didn't do the visual inspection first. So now maybe the damage is more more difficult at this point, because I tested it first before doing visual inspection and measurements. Point number two, in this case, I'm pretty much sure that this is not the case, that I broke it more by connecting load. What breaks in these obviously are the capacitors. That's going to be number one, that's going to break. and the spike of 1 volt on the output, and that's 100 milliseconds, tells me that it just started measuring the output voltage. Output voltage was too low, or maybe it was too high, but I can't see it on my scope because this is the 50 millisecond per division scale. The resolution of this scope is like really low, so I can't really tell. Maybe there was a spike to 16 volts or whatever, and that's what caused it to shut down. But either way, when this happens, there's almost certainly the reason are the caps. Almost certainly the reason are the caps on the output, because the PSU turns on, starts measuring, and then it needs to report back to the board whether the power is good or not. And it needs to do it in a way so it doesn't fry the board, because the board is still connected to all those voltages. It just relies on the SB voltage to just allow the user to click the button and turn on the board, or turn on the PSU. All right, let's just do this. I'm almost certain that these are the caps, but the possibility that I broke it by connecting such a big load without fixing the caps is still, I don't know, it is still plausible. Not very probable maybe, but there is a possibility. Okay, this is an unusual design. Let's see, because those things, okay, so we have, this is connected or screwed into the heatsink because this is connected to the fan. So we have some temperature sensing circuit that regulates, either turns on and off or regulates the fan. There is a button over here that will probably be connected to the same thing. Yes, it is. So this button is labeled as turbo fan switch. So it probably ignores the thermistor reading. So that would be my guess. Oh, and actually, let's unscrew this guy and unhook this part, so it should be easier. Now a few screws and we'll see the board, and I should discharge all the caps, but let's first of all, let's see if we get a solder. We do have to solder, that's for sure. And this is my way. Yeah. Or maybe the cables aren't long enough. Well, they're definitely not long enough. Oh, maybe. Oh, hang on. I see. Nice. There's a plug. this thing. Are they labeled? Am I gonna know? Oh, okay, so this is the switch. Are they labeled? Because if I disconnect it, I won't know which one's which. They're not labeled. I want to be guessing later, so let's mark this like that. Then I'll know. And there's one more over here. And that disconnects. And this is unfortunately soldered, but that gives me perfect access. Awesome. Since it was working before and stopped working when I connected the load, well, with caps it can be like that. I had the other device that came to me, it was cold, the device was cold, and the reason was a bad cap, and I turned it on, and it was indeed bad cap, it wasn't working, but then when it stayed in, it warmed up, and it magically started working again. So capacitors, the electrolytic capacitors, are actually what is it called? Electrochemical device, electrochemical element. So temperature, pressure, a lot of stuff can affect the performance of it. That's not gonna be it. I'm measuring, but I'm still gonna replace all the cups. So I think this is it. Oh, this one's working. But since on the scope I see the spike of 12 volts to about 1.2, so about 10%, and I see 5 volts spiking a lot lower, also around 5%, around 10%, but a lot lower voltage wise spike. So I expect that this 3300 is on 12 volts. Let's confirm. Yep, that's 12 volts. And I just measured the one on 5 volts, and it gives me open line. So most likely, so I can do this just to verify it. On 5 volts, I'm just gonna place a capacitor. I'm running low on these. But well, what are you gonna do? I gotta order some more on 10 volt caps. And this is gonna be like super quick soldering, just to confirm. No. Actually, I can just do it here. Like that. And this is the negative. Oops. Okay. And positive here. Was there? Oh, now it's better. How long has it been like that? Sorry about that. Okay, and this is 5 volts. Let's put some solder over here. Like so, and now, pretty much without changing anything, I'm not even gonna connect the fans because I don't need that. But this will quickly confirm if it's actually the problem on the cups. Where's that cable? Doesn't look that great, but oh, and now did I make the bridge? Okay, needs to be a little in the awkward position like this, but it's fine. Shall we do light bulb first, since it's so open? Yeah, let's do the light bulb first, just in case. This ain't electro boom channel. And let's check everything here, and I'll turn on. And there you go. So we got 5.1. See, this is still fluctuating a bit. 12.4, 12.5. But we got 5.1 on the output. Oh, and power good was late. So the cap needs to be definitely replaced. But it was very late power good signal. It's probably because of the 12 volts, and it is indeed fluctuating. It's not supposed to be doing that. It is high, but this is through the light bulb, so I'm gonna try to put load on it. This will cause it to turn off, and because the light bulb won't be able to deliver that much current. But let's just see what happens. Yeah, so the light bulb went on and everything else went off. Yeah, well, now it says power good 0 because yeah. So now, just for the sake of curiosity, let's put the unprotected circuit. And first, let's turn it on. Kinda don't want the heatsink to touch the casing. this is so sloppy. Okay, not this. Sorry about that. Alright, and there's my load. And let's turn it on. And let's do the load. Yeah. It's loaded right, but it went to 11.9. But we got 5.2 on 5 volts. So actually 5 volts is okay now, and 12 volts is suffering. And now, this went too hot, too hot. Yeah, now I can hear the sound, and this is definitely the sound. This is definitely the sound of the caps. Yeah, now it's dropping a bit. Yeah, and 12, well, this is, never mind. 12 volts is now stable at 12.4 because it got loaded, and or the load was on it, and it got the cap going again. So basically this is, yeah, and now the sound stopped. Yeah. This is basically the most common fault on PSUs, just bad caps, lack of capacitance on the output, and you can connect the tester to it and it'll show you that all the voltages are fine and the PSU is working fine. Until you put load on it, you're not gonna know. And this one would have fooled me, because, well, it did actually. I was obviously gonna replace the caps on it and, you know, do the whole procedure, but, you know, I just put it on the tester. It turned, you know, it gave me voltages, so I figured, okay, this one's fine. Misdiagnosed. No, it wasn't misdiagnosed. It was just maybe the difference in the you know, air pressure, because I'm high in the mountains. So, you know, maybe that's what made it work for a little while. Maybe temperature. Maybe the fact that it hasn't been used in maybe months, weeks, however long. It's hard to tell, but that's how caps can affect these devices. Alrighty, this one is not repaired just yet, but it will be, and I'm not gonna bore you with the process of actually replacing the caps. I'll do it off camera. And thank you guys very much for watching, and I shall see you in the next one.